Hey friends, I want to tell you about a new tool that we have to help you bootstrap some Talos nodes. There's plenty of ways to get Talos Linux on a machine. We have images for a bunch of different platforms and even just raw ISOs. So if you're booting something with bare metal, download the ISO, put it on a USB drive, plug it in, and you should be off to the races. But sometimes that's not very fun. Maybe you don't have a USB drive, or it's just annoying to manage files like that. So that's why we built a new tool called Booter. Booter is a simple DHCP proxy server that will offer PXE Boot to bare metal machines. And you might be wondering, like, where does this fit in with other tools that we have? We have things called infrastructure providers, and the infrastructure providers connect into Omni and do full lifecycle management for bare metal machines. They'll talk to IPMI, they'll shut down machines, they'll wipe them, they'll do everything that you would need to manage physical machines like it is a cloud environment, where it's just resources that get managed automatically for you. We also have dynamic infrastructure providers, like the KubeVirt provider, which will dynamically create and destroy VMs for you if you have virtualized machines that are dynamic, where they don't sit around all the time, they're not actually taking up physical space, so we can just create them on the fly. We have plenty of other infrastructure providers we want to create for virtualized environments, but Booter's a tool that doesn't do full lifecycle management and makes it easier than downloading files. So the idea was you could run one binary somewhere on your network and just boot a machine without needing to pre-download anything or configure anything else. If you already have PXE booting infrastructure in your network, we have endpoints for that. You can use Omni or the image factory and point your PXE infrastructure to those endpoints to automatically boot Talos. This isn't for you. Booter is for the other cases where you don't have PXE infrastructure, you may not have full lifecycle management, but you still have bare metal machines, you just want to get booted. And this really shines in a home lab or an edge environment where maybe I don't have all the resources that I might have in a data center. There are some limitations to what Booter can do. One is that you'll have to have a Linux machine to boot it. This won't work on a Mac because of the way that Docker on a Mac is still within a VM and doesn't have raw network access to the Apple host network interfaces. So you do need something that has that level of access. You could put this easily on something like a Raspberry Pi and carry it around with you. All you have to do is go on the Raspberry Pi, tell it to start Booter container and always restart. And then anytime you plug it into a network, it'll automatically figure out DHCP. It knows its interface and it'll start offering a PXE boot endpoint for you on the network. So let me show you how to get started and we'll just walk through the steps. So like pretty much all of our tools, this is packaged as a container. The one thing you will need is you will need network host because again, this is looking at the actual interfaces on your machine to be able to provide DHCP proxy access. And that's why something like a Raspberry Pi would work great in this scenario. So if we just do a -H at the end, it gives you some nice things around where the API actually gets advertised because this is, again, it's talking to your interfaces. If you have a lot of network interfaces on a machine, it doesn't necessarily know which one to pick, where it should be offering PXE boot endpoints. So you can set these to your interfaces that you need. You also can disable the DHCP proxy if you don't need it, and you can automatically include things like extensions. We'll go through all of that stuff. If you're running your own image factory, you can point this directly to your image factory in an air-gapped or edge environment that you don't want to use necessarily a public image factory. So let's just run it by default. Immediately it's going to start up. It does look at my network interfaces and starts offering on my first routable network interface. I will say that this machine does have quite a few different network interfaces, things that are virtual like Docker containers, Tailscale, all these things, and Booter just kind of figures it out. It knows, oh, this is where you route traffic. This is where you got DHCP. We're going to go ahead and try to use that network interface. So now over here, I have a KVM that's connected to one of the machines behind me on my bench, and we'll go ahead and boot it up and watch it go. I have a little command line wrapper that lets me PXE boot things pretty easily in my network. So that first machine is never, and we sent a wake on LAN packet to it, and then we'll just watch it come up. This machine is wiped already. There's nothing on it for it to boot locally from. If you have BIOS or anything configured, you'll want to make sure you set like the disk image first so that when it is installed, it's going to that first. And then on other devices, if there is nothing, it should network boot. Or sometimes you can set in a BIOS that if it receives a wake on LAN packet to boot from the network interface first, only on wake on LAN. So you'll see inside of Booter, I did get the request already coming through. And then if I switch to the interface, it already picked it up. It immediately went to say request DHCP, and now Booter is sending it the TFTP files that it needs to be able to boot Talos. And you'll see here in the interface that it's It's pulling images directly from the image factory. Like I said, we already offer all of these as PXE endpoints. Booter's just kind of a glue that makes it easier to use those endpoints. So this isn't anything new for us. We're just offering them for you to be able to kind of get started. And once the machine started PXE booting, you actually don't need Booter anymore. I can just kill this process. The machine has already started, it already downloaded the RAM and init disk and everything from the image factory. Booter's out of the equation now. This is just the initial DHCP offer and a small PXE file to say, go boot from the image factory. The machine and image factory handles everything after that. One of the other things I wanted to show you is how easy this is to customize how Booter's actually configuring machines as they boot up. So in this case, we can go to the image factory and start our customizations. Whatever it is we want to do, we can go through and say, I want a bare metal machine. One of the cool things is we have all these versions available, but we also have the pre-releases. So if I go all the way down to the bottom and select the 111 RC, as I'm recording this, 111 is not out yet. So we'll go next here. We'll say AMD 64 for my architecture. We could pick some system extensions, whatever it is that we want. We could customize the console if we want. And then this gives us a schematic where we could download this ISO and we could use this for installations. But all of this stuff, all these customizations are actually available in Booter as well. So if I go back to the command line here and look at Booter, I can go Talos version, and I can use whatever is available from the image factory. So that was v111 -rc.0, and then well, let me remember what the flag was for extra kernel args. I want extensions, and then these would just be the same extensions that we have here. So if I need, let's say, drivers or something in the system during boot, I can add these to my Booter environment. So this would give me like the Intel microcode, and I can just run it. And now that's going to use a different schematic ID. So if I wake on LAN another machine, and again, this machine is set to automatically boot from the network interface on first boot if there's nothing on the disk. So this should get me Talos 111 release candidate without needing to download anything, without needing to flash a USB drive, nothing like that. All I had to do was run this command and say, oh, I want 111 now. Let's go ahead and try it out. And here we go. Of course, if you have a slow or unreliable internet connection, this may not be the best option to try to download it directly from the image factory. You'll probably still want to pre-download some of these ISOs or run the image factory locally as well. And it's really hard to see in the screen, but it is 111 release candidate 0 that is now booted up in maintenance mode, ready to go. Where I think this really shines is something like Omni. In Omni, it just connects from anywhere in the world with a network connection. So again, let's say you have a Raspberry Pi that you go plug into a network, PXE boot a bunch of machines, and they just show up in Omni to become a cluster. So if you go to your home screen and copy your kernel parameters, that's the only thing you're going to need to make machines join this Omni instance. Let's go back in here to Booter. I don't need those extensions or versions anymore, and I'm just going to do a -K, which is my extra kernel args, and paste in my kernel args, which is how the Talos nodes know to find Omni. So let's go back in here and reboot these. So again, as those machines boot up, we'll see them start getting their TFTP files, and they're going to do all the same stuff they were for just a vanilla Talos install, which that's all Omni machines are, is they're vanilla Talos with a little bit of connection information. So once the machine is fully booted, it'll show up in Omni. So let's make that a little bit smaller as it boots up, and immediately, right when it comes to the dashboard, we already have our SetErrorLink connection. As it cycles and scans the hardware, all that's going to fill in here in Omni. There we go. We see all the hardware information. Those other machines are probably still booting. They should be here any second. While they're booting, we can, of course, make a cluster out of them. Let's just call it PXE. We'll get the latest versions of everything, because why not? We'll say one control plane, one worker node, create a cluster. And we can turn off Booter because, again, it's not needed anymore. The machines have already booted into memory. It's just like unplugging the USB drive or CD if you actually have a CD. So you don't need that anymore while it's going through this install. And after the machine is installed, it stays installed. So even if I wipe the node, remove it from a cluster, it'll still reboot back in to connect to Omni because it doesn't lose that connection information. They'll be connected until I go to the machine and power it off and wipe it, or go into Omni and tell it to remove the link. And just in case you didn't know, we actually do a kexec anytime we do an install. It's a really fun little thing where you'll see it here, 1623, it does a kexec. That's the reboot. And then 2 seconds later, it's already rebooted. It's come back up because a kexec doesn't actually need to go down all the way to the BIOS and reconfigure the hardware. So even if my booter system was still running, the machine wouldn't PXE boot again because it doesn't go through a whole UEFI post flow for powering on. It never actually shuts the OS completely down. The kernel just switches to the new installed version instead of the one that was running in memory. And there you have it, a healthy running bare metal cluster created without downloading anything ahead of time. Because of technologies like SidearrowLink making a WireGuard VPN out to Omni, and things like CubeSpan that can make a node-to-node mesh VPN between all the nodes in your cluster, you can boot these instances from anywhere on pretty much any network and just get them connected without needing to download ISOs or carry USB drives around. Booter is the latest way that we want to just make it as easy as possible to get up and running with a Kubernetes cluster anywhere, and that includes bare metal and edge. So go ahead and give it a try and let us know what you think. Thanks everyone for watching, and we'll see you next time.